Have you ever wondered what happens inside a car when you press the clutch pedals? Or why do you need to press the clutch pedal before shifting gears in a manual transmission car? This video gives you a logical answers to these questions, and at the end of this video we will also understand the crucial role played by the clutch in an uphill start.
Ayush Kumar from Mechanical Film Center. I am going to know about the topic of the anatomy and functioning of the clutch. To understand the need for a clutch, let's first understand the anatomy of internal combustion engine car. Internal combustion engines have a very limited torque band, so in order to efficiently vary the speed of the drive wheels, internal combustion engine cars needs a transmission system. The use of the transmission systems makes sure that the engine is work within the optimum RPM range, and by changing gears according to the driving condition, the transmission helps the control to drive wheels speeds. Now, in a manual transmission car, making these gears change is not an easy task. To have a smooth gear change, the engine power flow to transmission has to be discontinued. However, it's not a practical to turn off the engine just for the gear change. That's where the clutch comes in. In short, the clutch is a mechanism to disconnect the flow of the power to transmission without turning the engine off.
Working of the clutch. The main part of the clutch consists of a disc coated with high friction material on both sides. A simplified clutch disc is shown here, and this disc sits on the flywheel. If an external force presses against the clutch disc, it will also turn with the flywheel due to frictional force. The input shaft of the transmission is connected to the disc. So when an external force is applied to the disc, the engine power will get transmitted to the transmission system. This external force is provided by the pressure plate spring system. The cover of this system is attached firmly to the flywheel. So the pressure plate will firmly pressed into the frictional clutch disc, and the engine power will be transmitted to the transmission system. But this is the case of normal driving. So how is the power disengagement done with the clutches? For the disengagement purpose, a special kind of spring is introduced in the pressure plate assembly. This spring is known as diaphragm spring. To understand this diaphragm spring better, assume that the diaphragm spring's motion is fixed around the circle. In this case, if you press the center of portion of the spring as shown, the outer portion should move in the opposite direction. The diaphragm spring sits between the pressure plate and the cover. Let's take a cross section of the assembly to understand this configuration better.
The outer portion of the diaphragm spring is connected to the pressure disc. This means if you press the inner portion as shown, the pressure disc will move away from the friction disc and thus discontinuing the power transmission to flow. A hydraulic system transfers the clutch motion to the center of the diaphragm spring. When the diaphragm spring is pressed, the power flow discontinued, and during this time you can make a gear change. The clutch is released after the gear change and the power flow continues again. This is how the clutch works. In an actual clutch, you can see a few coil springs on the clutch disc. These are used to smooth out most of the fluctuation and vibration from the engine output. It is clear that the hub and disc are not directly connected. The power output from the engine first reaches the disc, then it transfers to the spring and finally to the output hub. This means that the spring will dampen out most of the power flow fluctuation and the motion transfer to the vehicle will be much smoother. Now let's discuss an extremely important and difficult task in driving car with manual transmission. Starting from uphill, how does it work? Even in a car without handbrake, you can use this clutch technique to start while pointing uphill. In an uphill start, initially both the brake and clutch pedal are pressed while the engine is running. Now release the clutch pedal partially until you feel the clutch bite. Clutch bite can be experienced as your feet may feel like shivering at this point. Even if you release the brake pedal, the vehicle will not roll. The partially pressed clutch acts like a brake. Now you can press the gas pedal and the vehicle will move forward. Now the biggest question here is, how does the partially released clutch act like a brake? This brake phenomena is nothing but a game of force balance. In a perfectly force balanced condition, the wheel of the vehicle will not be able to roll and the gravitational pull will be same as that of the static frictional force acted on the wheel. The wheel of the vehicle are prevented from rolling by another force balance.
The big question here is how does the partially released clutch act like a brake? This brake phenomenon is nothing but a game of force balance. In a perfectly force balanced condition, the vehicle wheels will not be able to roll, and the gravitational pull will be equal to the static frictional force at the wheels. The vehicle wheels are prevented from rolling by another force balance. Force balance between the engine forward force and the same static frictional force. When you partially release the clutch and it balances from the clutch pedal, you are unknowingly doing all these force balances. When these forces are in perfect balance, the wheels, the transmission system and the clutch disc will not be able to spin. This is how the clutch bite acts as a brake. But remember, the frictional force between the rubbing surface produces the engine forward force. In this case, this will result in wear and tear of the friction material of the clutch disc.